All right, for section 4.1, our first objective wants us to be able to identify polynomial functions by degree and write in standard form. And also I think I need to add, not only do we be able to identify the degree, but we should be able to say what the type is, and the type comes from the degree. And so when we say type, we're talking about anything that's x to the first power. Well, that's linear because we get straight lines out of those. Anything that's x to the second power, well, that's quadratic. And so we'll look at that, and let's just make sure we can identify the degree and make sure that we can put it in standard form. All right? So this right here is a polynomial. Okay, I'm going to tell you that, and if you'll notice, it has an exponent of 3 here. This is called the leading coefficient, by the way. It has an exponent of 2 here, an exponent of 1 there, and technically, for the x to be completely not represented, it would have to have an exponent of 0, wouldn't it? Okay? And so can you see how the exponents are going in descending order from big to small? All right? The degree of this polynomial is 3. It's the biggest exponent you can find. If down here at the end I would have had a 7x to the 4th, then the degree would be 4, and the leading coefficient would be 7. And if the x to the 4th was down here, then this wouldn't be in what we call standard form. Standard form needs the exponents written from biggest to smallest. All right? That's what standard form is. It's a degree 3. What would we call the type then? Well, we would call that cubic. All right? Cubic, because cubing, when you have things to the 3rd power, you cube that. Things to the 4th power, well, the word is quartic. All right? To the 5th power, we usually just call them polynomials. But that's what we're looking for here. All right? Hey, know that polynomials have to have exponents that are integers, okay, so no fractions, and they have to be positive. Okay, you could be 0 also. We just saw that here, didn't we? All right, but no negatives, and that's why. And if you read a textbook, you'll probably see someone use the terminology non-negative integers. All right, so let's look at some. All right here. Is this a polynomial? Well, let's look at the exponents. 3, 4, that's a 0, and that's a 2. Are they all integers? Yep. Are they all 0 or bigger? Yep. Is it written in standard form? No, it's not. To be written in standard form, we need the 5x to the 4th first, plus x cubed, plus 2x squared minus 1. Now that is in standard form because the exponents are going down from big to small. Okay? What about this one right here? h of x equals 7x minus radical 2 plus 8x squared. All right? Is this a positive exponent? Yep, it is. Is this a positive exponent? And we got to think back. What is the square root sign? Isn't that an exponent of 1/2? Is this an integer? No, it's not, and so this is not a polynomial. Okay? What about right here? 2 to the x minus 1, all right? What's the exponent here? Oh, it's an x. That's not a polynomial function. That's an exponential function, and so this is not a polynomial. Right here, do you see anything that might send off alarms? Yep, I do. Can't have a -1 as an exponent if we're dealing with polynomials. So that's not either. All right, what about this last one here? Is this a polynomial? Well, this pi sign, that's kind of crazy. But is it an exponent? No. And what is pi, by the way? Well, it's just a number, right? It's 3.14, and it keeps on going. So that's okay. The exponent's 3 and 1. That's a polynomial. Is it in standard form? Yes, it is, because the exponents are going down. There isn't an exponent of 2, so it goes from 3 to 1, and we're done. Okay? There you go. Identifying polynomials by degree and type, and knowing when you don't have one. Good luck.